Hi, this is your Professor Sudha Kolathuparambal. Find any relative extrema of a function. Here we are going to use the first derivative test to find the relative extrema of the function. This is a polynomial function, so the domain will be all real numbers. First we will find the critical values by taking the derivative and setting it equal 0 and solve. So take the derivative, apply the power rule, so 12 x square, 9 times 2 18 power 1 because we are subtracting 1 from the exponent. Negative 30, derivative of x is 1, that's why we didn't write 1. Derivative of 25, 25 is a constant, derivative of a constant is 0. All these numbers has 6 as the common factor, factor out 6. Divide each number by 6 to get the other factors inside the parenthesis. If I divide both sides by 6, 6 will be gone. Now factor again. In order to factor this, you can use the trial and error method, or you can use the grouping method and factor. Then set each factor equal 0 and solve. So we got two critical numbers here. One is a negative value, other one is a positive number. So these are the values where the relative maximum or minimum exist. But we need to check this is actually a maximum, relative maximum or relative minimum. Remember, relative maximum and minimum are the y values. So first we will draw a number line. Number line means that is the domain. So here domain is negative infinity to infinity. Then mark the critical numbers at this number line. Then list all the factors of f prime here. So factors of f prime is 6 times 2x minus 5 and x plus 1. That means if I multiply all these, I will get this one, that is f prime. So I am just listing the factors of f prime and take test point from each interval and substitute the value here to check the sign. So in this interval the test point is negative 10. If I substitute negative 10 here, negative 20 minus 5, that is a negative number. Negative 10 plus 1, that is a negative number, negative 9, right? Then in this interval I am taking 0 as test point because the calculation will be easier if I pick 0. I can take 1 as test point if I want. I am taking 0, so substitute 0 here. 2 times 0 is 0 minus 5, that is a negative number. 0 plus 1, that is a positive number, so put positive. In this interval I am taking 10. You can take any number in this interval. I am just picking 10 because multiplying by 10 will be easier. So 10 times 220 minus 5, that is a positive number. 10 plus 1, that is 11, that is a positive number. Since we are multiplying all these factors to get f prime, I am going to multiply. So if I multiply two negative, I will get a positive number. If I multiply a negative and a positive, I will get a negative number. If I multiply two positive numbers, I will get a positive number. So these are the sign of f prime in this interval. So f prime positive in this interval means the original function will be increasing in that interval. F prime is negative in this interval means original function f will be decreasing in this interval. And original function will be increasing in this interval because f prime is positive in that interval. So if a function is increasing and decreasing, there will be a maximum, right? Relative maximum. If it is decreasing and increasing, there will be a relative minimum there. So relative maximum will be at x equal negative 1. Relative minimum will be x equal 5 over 2. So these are the values where relative maximum and relative minimum occurs. Remember, relative maximum and relative minimum are the y values, so we need to find the corresponding y value. So substitute this value into the original function here to find the corresponding y values. So relative maximum is 42, relative minimum is negative 175 over 4. Or relative maximum point is, if we are talking about the point, x coordinate and y coordinate. This is the x coordinate, this is the corresponding y coordinate. But we are talking about the relative maximum and minimum, and those are just the y values. This procedure to find the relative maximum or relative minimum is known as the first derivative test. Let's look at one more example to find any relative extrema, then sketch the graph. So this is x square and e power negative x. X square is a polynomial, domain is all real numbers. E power negative x, it will be a decreasing graph. The shape of the graph will be like this. So domain is all real numbers. So the product of these two functions, the domain will be still negative infinity to infinity. First we will find the critical value by taking the derivative. Since this is product of two functions, we need to apply the product rule. So f prime g plus f g prime. Derivative of x square is 2x. Derivative of e power negative x is e power negative x times the derivative of this exponent. Derivative of negative x is negative 1. So here I use the chain rule. Now I can see that both has x as a common factor, also e power negative x also a common factor. That means this is the GCF, and divide each factor by the GCF to get the other factor. So other factor will be 2 minus x. Now you can see there are three factors. Set each factor equal 0 and solve. So x equals 0, e power negative x, that is this graph, this is not crossing the x-axis, so no solution. And 2 minus x equals 0. If you add x on both sides, x equal 2. So there are only two critical values, those are 0 and 2. Now draw a number line. This is the domain of this original function, and mark this point on the number line. List all the factors of g prime and take test point from each interval. Now substitute negative 1 in each factor to make the sign chart. So negative 1 will be a negative number. E power negative of negative 1, that is e power 1, is a number, so that is a positive number. Then 2 minus negative 1, that is 2 plus 1, that is 3, that is a positive number. Now from this interval I took 1 as the test point. Now substitute 1. So 1 make all these factors positive. Then test point from this interval is 3, so that will be a positive number. This is also a positive number. 2 minus 3, that is negative 1, that's a negative number. G prime is, you can see that is the product of these factors. That means if you multiply these number, a negative number and two positive number, if you multiply, you will get a negative number. If you multiply all positive numbers, you will get a positive number. If you multiply two positive number and a negative number, you will get a negative number. These are the signs of g prime of x in this interval. G prime negative means original function will be decreasing in this interval, and positive means original function g of x will be increasing in that interval. So if the function is decreasing then increasing, there will be a relative minimum at x equals 0. If a function is increasing and then decreasing, there will be a relative maximum at x equal 2. Now substitute these values into the original function to find the corresponding y values. If you are talking about the relative, at what point the relative minimum or relative maximum existing, we can write it as an ordered pair x comma y, the corresponding y value. And if you graph this, this is 0 0 when x equals 0, that is 0. When x equal to 2, that point is this one, that's a positive, both are positive values. In this interval, negative infinity to 0, you can see that that is the function is decreasing, so this is decreasing. Then 0 to 2, the function is increasing, so going up. Then after 2, the function is still decreasing. Find the critical value of this function. So first apply the power rule, then use the chain rule. So bring the exponent in front of that, inner function stay the same, subtract 1 from the exponent, then multiply by the derivative of the inner function. Derivative of 1 is 0. If you subtract this, that is negative 1/3. Since the exponent is negative, I move that to the denominator so that the exponent will be positive. Now this factor, you can see that if x equal to 2, this will be 2 minus 2, that will be 0. 3 times 0 will be still 0. So it will become 2 divided by 0. That means f prime will be undefined when x equal to 2. So the critical value is x equal to 2. The definition of critical value is when f prime is equal 0 or f prime undefined. Here f prime is never equal 0 because we cannot set this equal 0 and solve, because then we will end up with 2 equal 0. That is not possible. So now we will check whether f prime is undefined or not, and we can see that f prime is undefined when the denominator is 0. That is when x equal to